Hi everyone, welcome to lesson 11.1, Graphing Quadratic Functions. Your objective: I can analyze graphs of quadratic functions, I can graph quadratic functions by using key features and tables, and I can use graphing calculators to analyze key features of quadratic functions. Our vocabulary today, there's obviously quite a list. Some of these you've already heard about, so we'll just go kind of through them quickly. We have a quadratic function, which is an equation of the form y equals ax squared plus bx plus c, where a does not equal 0. The leading coefficient determines end behavior. So that leading coefficient, again, we're talking about that a. A parabola, that's the graph of a quadratic function. The axis of symmetry, that imaginary line where the graph reflects. A point on the left side will correspond with a point on the right side of the axis. We have a vertex, and that's the point of the parabola that lies on the axis of symmetry. The minimum, which is our lowest point, and the graph opens up. A maximum is the highest point, and the graph opens down. We have our x-intercept, where the graph crosses the x-axis. There could be no x-intercepts, there can be one x-intercept or two x-intercepts. It also can be referred to as the roots of the equations or the solutions to an equation. And I would highly suggest underlining that, because if you are asked for the roots of the equation, you need to understand that they're talking about those x-intercepts. And we also have our y-intercept, and that's where the graph crosses the y-axis, and there will only be one. Now the first part of this is we're going to identify those characteristics on a graph or from a graph. So the directions tell you to identify the axis of symmetry, the vertex, and the y-intercept of the graph. Then describe the end behavior. So if we take a look at our axis of symmetry on this first one, so remember the axis of symmetry is that kind of line that cuts that parabola in half. Okay, so it's that direct middle of that parabola. So if we kind of take a look at this graph, we can see that that line is going to be, the middle would go right down right here. So that would be our axis of symmetry. So remember that the axis of symmetry is a line. So when you write down that axis of symmetry, it has to be an x equals. If it doesn't say x equals, it's not correct. Okay, and in this case, x equals positive 1. So x equals 1. Goes right through that 1 on our x-axis. Okay, so remember what the vertex is. The vertex is that point, and that's going to be right here. And that's the point where the axis of symmetry cuts through that parabola. So if we take a look, remember that that's a coordinate point. So that point is at 1, -4. So our vertex is always at a coordinate point. You have to have that x and that y value. Then we're saying, is this a maximum or is this a minimum? So again, we look at that vertex and we say, is that the bottom? So is that a minimum of that parabola or of that quadratic function, or is it a maximum? We can see that this is the lowest point, so we know that that's a minimum. It's the lowest point, so it's going to be that minimum. Okay, and then they ask for the x-intercept and the y-intercept. So again, our x-intercept is going to be those points where remember, there could be 0, there could be 1, or there can be 2. In this case, we do have 2, and there's 2 points there where the graph crosses the x-axis. So our first one is at -1. Oops, I need a darker color for that. So -1, and our other x-intercept is at 3. So -1 and 3 are our x-intercepts. Our y-intercept is where does it cross the y-axis at? Okay, and we can see that that graph right here crosses the y-axis at -3. So those are the points that we're trying to find from the graph. We'll be figuring all these out later, but for now we just need to know what they are. Okay, so if we take a look at this second one, we remember that that axis of symmetry is our middle. So if we take a look at this, and it's usually designated with a dashed line that cuts through that parabola, We can see that that cuts through at, remember it's always an x equals, so x equals, and it cuts through at 0 on the x-axis, so that's x equals 0. The vertex is that point where it comes down, either lowest or highest. In this case, that vertex is at 0, 0. So that's what we need to put in there. Our maximum or minimum, remember we're picking, is it a minimum or is it a maximum? And that parabola does open up, which tells us that we do have a minimum. That's that lowest point. And then again, that x-intercept, remember it can be, we can have none, we can have 1, or we can have 2. In this case, we do have 1. It intersects the x-axis at 0. Okay, so this one only has 1 x-intercept. And then our y-intercept, where does it cut through the y-axis? It also cuts through the y-axis at 0. So our x and y intercepts are the same on this one. So go ahead and try the U-try, and then come back and check to see if you are correct. So let's take a look at the U-try. So on this one, again, we take a look, and our axis of symmetry, that line that would cut that parabola in half, and is our line of reflection, is at x equals, and we take a look at the graph, and that is at -1. Okay, this graph only is labeled every 2, so again, we have to take that into account. Our vertex, so we take a look at where that parabola crosses that axis of symmetry, and we see that at -1, 4. I'm going to fill that in. And if that is a maximum or a minimum, our parabola is opening downward, which means that that vertex is a maximum. That's the highest point of that parabola. And then again, we take a look at our x-intercepts. So we take a look and we see we have 2 on this one, those bright green dots. So we can see that those are at -3, and the other one is at 1. So we have 2 x-intercepts on this one at -3 and 1. And then we take a look and find our y-intercept. And again, we look at our y-axis, look up and down and see where does the parabola cross the y-axis at, and it crosses it at 3. So that's that first one. Okay, so if we take a look at the second one on the U-try, and this one's going to be a little bit different because it's not going to be quite as plain to see. And I look for that axis of symmetry, and I can see that the middle, this graph is a little bit harder to see. It's kind of faint, but we can do the best that we can here. So if we take a look, it looks like that axis of symmetry goes straight down. The part about this that we have to be careful of first is we know it needs to be an x equals. But the second part is this graph is a little bit different. If you can tell, this would be -1, which means where our line at is -1/2. Okay, and you can write -0.5 or -1/2 with a fraction. It doesn't matter either way. But we can see that that's a little bit different than we've had, again, making sure that you're reading the graph correctly. And then when we go to look at the vertex, so if our vertex is right here, then we have to, again, take a look at the graph because the graph is a little bit different. Okay. So that vertex lies at that -0.5, because remember, your vertex is always the same as what your value of your axis of symmetry is, because remember that the vertex lies on the axis of symmetry, so that x value has to be the same. And then we go over to kind of look at our y-axis. If we kind of trace that over to the y-axis, again, this is a little bit different because of the way it's numbered, but this would be -3, so our dot is like halfway between -3 and -3.5, so that's going to be -3.25. Again, a little bit different and kind of hard to fit in there, but just do your best. Okay, the next part's pretty easy to answer, maximum or minimum. Okay, the parabola opens up, which means that we do have a minimum. That vertex is the lowest point on our parabola. And the x-intercept, again, is the kind of different one because it's not exact, but we can do our best. So if I kind of blow that up a little bit, we can tell here that our x-intercepts, they're about in the middle of those. So we're going to estimate those and say that our x-intercepts, and again, remember, this is 1, okay? So that's almost to 1.5, so that's halfway between 1 and 1.5, so that would be 1.25, about 1.25, because we can't be exact on that. And then this one over here is at negative 2.25. Okay, so a little bit different just from reading the graph. And then the y-intercept, that one's a little bit easier to see. And if I get rid of the stuff that we had before, you can see that that crosses at negative 3 on the y-axis. So our y-intercept is negative 3. So now that we can recognize these, now we're going to be trying to figure those out as well. Okay, so moving to that second page, we're now graphing quadratic equations. So we need to be able to find the axis of symmetry and find that vertex from our equation. So the thing that I want you to understand is your coefficient of x squared is your a, your coefficient of your x is your b, and your constant is your c. So again, remembering that when we have to put it into these equations and things is just going to be helpful. Okay, so remembering that your equation for the axis of symmetry is negative b over 2a. Okay, so negative b is negative 4, so we've got negative 4. And then our a is 1 because there's not anything in front of our x squared, so we know that that would be 1. So if we simplify that, we've got negative 4, which we know is actually positive 4. And then 2 times 1 is 2, so 4 divided by 2 is 2. So our axis of symmetry is x equals 2. Then if we take a look at finding the vertex, remember our x value from our axis of symmetry is always the x value of our vertex. So we can go ahead and put that right in that coordinate pair, and that's what we're substituting into the equation. Remember, this is our original equation up here. And everywhere that we see x, we know that x equals 2 because that's what we found in the first step, and we're going to substitute that 2 in for that x. So it's already kind of written out for you, so we're just substituting in that 2 instead of x, taking the x out, putting the 2 in. Okay, and then we have to figure out what y is. So 2 squared would be 4. Negative 4 times 2 would be negative 8, and then we still have that plus 1. So 4 minus 8 would be negative 4, plus 1 would make that negative 3. So our vertex is at 2, negative 3. And then it says determine if that vertex is a minimum or a maximum. So how do we do that without a graph? So if we take a look up here at our equation, what we need to remember is that if our coefficient, our leading coefficient, which means that a, that number in front of x squared, if that's positive, the parabola is opening up. If the number is negative, it's opening downward. Okay, so this is a positive 1. So we know it's opening up, and whenever that parabola opens up, we know that we have a minimum because it's going to open up, and if you take a look at your examples from the front page, you'll see that if it opens up, that you have a minimum because you will have a lowest point. Okay, this step 4 is finding the y-intercept. Now remember, the y-intercept is always when x equals 0. So if we substitute 0 in for x into our original equation, and notice that's what we've done, everywhere there was an x, we've put a 0. Okay, so we have 0 squared minus 4 times 0 plus 1. So 0 minus 0 plus 1 is 1. So we know that that y-intercept is 0 for the x and 1 for the y. And then down here, we're going to make a table of values with the vertex in the center. So what does that mean? The vertex up here, so the vertex that we found was 2, negative 3. So we're going to put that in the middle box. because if we put 2, -3 in that middle box as the center, then we can do a couple points that are our x value is a little bit less, and we can make a couple values where our x value is a little bit more. Okay, so in this case we have a 2, so we're going to go down by 1, so we'll make it 1, 0, and then we'll go up by 1 on the x. Then we need to find those y values. Okay, we kind of already did that with the 0, because that was right here, when we found that y, because whenever x equals 0, we have that y-intercept. So we already figured out that if x is 0, y is 1. Now for the other ones, we have to put in those values to be able to see what that value would be. So if we look at our equation again, remember our equation was, I know we're not leaving you a lot of room to work this out, but x squared minus 4x plus 1. Okay, so now we're going to stick 1 in there for x. Okay, because this is a y equals. Remember, we're trying to find y. So if I put a 1 in there, I've got 1 squared minus 4 times 1, and then plus that 1. So 1 squared is 1, -4 times 1 is -4, and then plus 1. So 1 minus 4 is -3, -3 plus 1 is -2. So I can fill that one in. And then I'm going to do that same thing with the 3 and the 4. So if I go ahead and do the 3 as my, I'll draw a little line to separate those so you don't get confused. Okay, so if 3 is my x, it would be 3 squared minus 4 times 3. Sorry, I'll make that a little bit bigger. 4 times that 3, and then plus 1. Okay, so 3 squared would be 9. -4 times 3 would be -12, and then plus 1. So remember, these are all y equals. So that's what we're trying to figure out. So 9 minus 12 would be -3, plus 1 would be -2. And you're going to see that mirroring of those points. Okay, so if I try the 4, so again, y equals, and I'm going to do 4 squared minus 4 times 4, because remember, I'm substituting 4 in for x from the table, and then plus 1. So again, if I work that out, 4 squared is 16, -4 times 4 is -16, and then plus 1. So I have 16 minus 16, which is 0, plus 1, so y would be 1. So again, I can fill that in my table. And again, you guys could see that mirroring, 0, 1, 4, 1, 1, -2, 3, -2, and that's that mirroring we see where we could reflect that parabola onto itself. And that shows up in our graphs like it did on the front page. So go ahead and turn to the next page. So now that we've figured out the points in the table, we're going to go ahead and put those on the graph. So my first point was 0, 1. And then I have 1, -2, 2, -3, 3, -2, and 4, 1. Okay, so again, when we draw a parabola, remember it's round, it's not pointy. So when you go down, you're going to make sure that that's round, that it's coming up, and you've got arrows on the ends. And we've already kind of done this at another point, but for now, this is what we have to remember that we did before. Okay, so that's the graphing. So what we're going to do right here is we're going to take an equation and we're going to find all the pieces and graph it. Okay, so for this one, the first part of this is to make sure that we understand what A, B, and C are. Okay, so A equals 3, B equals 12, and C equals 5. Okay, so when we find that axis of symmetry, remembering that our axis of symmetry is -b over 2a. So I'm going to look at my values that I have up here, and it says that b is our coefficient of our x, so that's 12. So it's going to be -12, and it's over 2 times a. Our a is 3, so we have 2 times 3. So that's -12 divided by 6, so that makes our axis of symmetry -2. Remembering again that an axis of symmetry has to be x equals. So we've got x equals -2. Then remembering again, when we go to that first x, that's a coordinate point, and the x value is always the x value we just found from our axis of symmetry. So, because it has to be found on our axis of symmetry, so the x value has to be the same. So we've got -2, and then we have to figure out what that y value would be if x is -2. So if we take a look at that equation, and we put that in, so we've got 3 times, and if this is -2, that's going to be squared, and then plus 12 times -2, and then plus 5. And again, remember, we're getting that up here. So we're trying to find what that y is if x is -2. So then we're just doing the math part. Okay, so -2 squared is 4, so we've got 3 times 4. 12 times -2 is -24, and then we've got the plus 5. So we've got 12 minus 24 plus 5. So 12 minus 24 is -12. -12 plus 5 is -7. So y equals -7 for our vertex. So we're going to go ahead and fill that in. So our vertex is at -2, -7. Okay, again, ask us, is that a minimum or a maximum? And again, we can see that our a, that value right here, is positive, which means that that parabola is opening up. So it means that that parabola is going to have a minimum because it's going to be opening up. So it's going to have a lowest point. And then again, we need to look for our y-intercept. So where is that parabola crossing the y-axis? Remember, that is always when x equals 0. So sometimes that can just be the number, where does it cross, but always remembering that that's when x equals 0, so we could actually write it with our 0 in a coordinate point. So I would have 3 times 0 squared, which we know will be 0, plus 12 times 0, which again we know will be 0, and then plus 5. So 0 plus 0 plus 5 gives us that y equals 5. Okay, so our y-intercept is at 5. So again, when we go to write that table of values, we want to put that vertex in the middle and kind of work out from there. So if I write that down, I've got -2 and -7. So I want to go a few smaller than that and a few bigger than that. So a few smaller, -3, -4, a couple bigger, each one I'd have -1 and 0. Okay, so if I take a look at this, I already know the -2, -7. I know from right here that if x equals 0, my value for y is 5. So I really only have to figure out 3 of these. So yes, it does take some work, and I understand that. But you can use your calculators. That's not too bad. So if we take a look at -4, and when I return on Tuesday, I will show you how to do these with the calculators. We might need to switch to the other calculators, but it'll be fine. Either way. So -4, we're going to go ahead and put that in. So we've got 3 times -4 squared. Again, remember, we're using this original equation up here. Plus 12 times -4. And then plus 5. So 3 times 16. Be careful that you're putting that into your calculator correctly. And then minus 48 plus 5. 48 minus 48 plus 5. So 0 plus 5. Remember, these are y equals. So y equals 5. So at -4, our y will be 5. And then if we take a look at, and again, you can see that kind of mirroring there. So we can, again, find out what -3, so we're going to do that same thing. So y equals 3 times -3 squared plus 12 times -3, and then plus 5. So 3 times 9, and then minus 36 plus 5. 27 minus 36 plus 5. We can add those up ourselves or do it on the calculator, whatever works for you. We would have -9 plus 5 with y equaling then -4. So again, we can go back up here, put our -4 into our table, And we could also do that -1. If you wanted to, you could see the mirroring. And you could even if we left -1, that would be kind of interesting. We'll graph the rest of those and we'll kind of show the mirroring of those sides. So let's graph what we have so far. Okay, so we have -4, +5. We have -4, +5, -3, -4. Our vertex at -2, -7. And then not putting in the -1 yet, and then our 0, +5. Okay, so if we can kind of see that mirroring where the 2 5s up at the top where y equals 5, we could kind of see that does that mirror that -1? It does. So that would be at -1, -4. Okay, that same kind of thing. And again, then we are going to try to draw best as we can. We know that these are not perfect. Neither are mine. Okay, and our parabola opens up, which again, you can always check your minimum maximum, but just knowing that that A is, that leading coefficient is positive, we know that that parabola is going to open up, which means we would have a minimum. Okay, on the next page, we're going to do that same thing. So again, looking at our A, B, and C, our A equals -2, our B equals 4, and our C equals -3. Do you have to write that out? No, but it can be helpful. So again, we're looking at our axis of symmetry. So we know with our axis of symmetry, we have -b over 2a. So we have -4 over 2 times a, and our a is -2. So we have -4 over -4, which is 1. But remember again, when you put this in here, that's x equals 1. Okay, we don't want to forget that that's an x equals equation. Our vertex, then again, we can start off with our parentheses. We know that our x value of the vertex is the same as our axis of symmetry, so that's a 1. And then we're going to need to put that into the equation to see what we would get. So we've got -2 times 1 squared plus 4 times 1, and then -3. So if I kind of work upwards here, 1 squared is just 1. So 1 times -2 would be -2. 4 times 1 is 4. And then we've got -3. So again, remember these are y equals. So we're trying to figure out what y is. -2 plus 4 would be 2. 2 minus 3 would be -1. So my vertex is going to be at 1, -1. And then if I look to that, is that a minimum or a maximum? That is a parabola which opens. If I take a look, my leading coefficient is negative, so that parabola is opening down. So that means that I have a maximum. That vertex is going to be the maximum point on my parabola. So again, now to find the y-intercept, remember that's always when x equals 0. So if I put a 0 into that equation, I'd have -2 times 0 squared plus 4 times 0 minus 3. We know that this equals 0, this equals 0, and then we have a -3. So 0 plus 0 minus 3 is -3. Okay, so we filled out all of those. Now we need a table of values to be able to, excuse me, to be able to get some more points so that we can graph our parabola. So we know again that we're going to start with that vertex in the middle. So we've got 1, -1, and again I'm going to go a few less and a few more. So we're just going to go down by 1 and then up by 1. And we already know that our 0 is -3. So again, we don't have to figure out too many. And then I can go ahead and put those into the equation. So again, if I put this -1 in, I would have -2 times -1 squared plus 4 times -1 minus 3. So -1 squared is +1. +1 times -2 would be -2. 4 times -1 is -4. and then minus 3. So remember, these are all y equals. That's what we're trying to figure out. So negative 2 minus 4 is negative 6. Negative 6 minus 3 is negative 9. So I figured that out. So then I take a look at, are these probably mirrored on the other side? Probably, but we can always check. You can go ahead and work each of them out. You can try them on the graph if you want before. Let's maybe do one more of those. So let's do the 2 and see if it is mirroring. So negative 2 times 2 squared. Yeah, this is our y equals. And then we have plus 4 times 2 minus 3. So again, negative 2 times 2 squared. 2 squared is 4. So negative 2 times 4 would be negative 8. And then we have plus 8, because 4 times 2 is 8, minus 3. Negative 8 plus 8 is 0. 0 minus 3 is negative 3. I can see again that those are mirroring, so I'm going to go ahead and put that negative 9, and I can always check when I draw that graph. So let's take a look. So we're going to graph all these points. So we have negative 1, negative 9. Be careful this one just because the numbers are kind of in the way there. We have 0, negative 3, 1, negative 1, 2, negative 3, and 3, negative 9. See if that works out for us. If our line of symmetry would be going, because we said it was at x equals 1. That's a little crooked there, sorry about that. We can see that those would mirror each other. So I'm going to go ahead and draw the parabola as best I can. And we can see that those points do work. Okay, so the next part of this is we're just calculating the features. So basically doing a lot of the things that we just did without doing a table or doing the graph. So again, axis of symmetry being that negative b over 2a. Here's our a, here's our b, here's our c. So we know that a negative b is already negative 8. So that would be negative 8, which would be a positive 8. Okay, and then we have times 2a, so 2 times negative 2. So that would give us positive 8 over negative 4. 8 divided by negative 4 is negative 2. So our axis of symmetry is x equals negative 2. Please remember that if it doesn't have the x equals in front of it, it is going to be wrong, because it is wrong. It's a line, so it has to have that designation. And then we move to our vertex, which we always know that the negative 2 that we found is always that x value that goes there. And then we have to put that negative 2 into the equation. So I'm going to go ahead and work that out over here. Again, you guys can do some of this on your calculator if that works for you. So we've got negative 2, but I want to show you how we're finding it with what we have here. So again, our axis of symmetry is negative 2. Our leading coefficient is also negative 2. So we've got negative 2 squared minus 8 times negative 2, and then plus 2. So if we work that out, we've got negative 2 times 4 plus 16 plus 2. So negative 8 plus 18. So that would give us positive 10. And again, that's our y equals. So if our x is negative 2, then our y is 10. Okay, now we have to say, is that a minimum or a maximum? So we've got a negative leading coefficient, so that means our parabola is opening down, which means that we have a maximum. And then our y-intercept is always when x equals 0. So if we take a look and we put a 0 into the equation, we would have our y equals negative 2 times 0 squared. And then minus 8 times 0 plus 2. So 0, whatever, plus 0 minus 0, however you want to look at that, plus 2. So our y-intercept is going to be that 2. Okay, remember that sometimes it can be written as 2 if they're just asking for that. Generally, that is a coordinate pair, so that would be written as 0, 2. Okay, next one. Same thing. Okay, we're just finding all those features. So we're looking at trying to find that axis of symmetry. Our A is 2, our B is 4, and our C is 6. So negative B would be negative 4. Our 2A would be 2 times 2. So we'd have negative 4 over 4, which would be negative 1. So remember, our answer has to be x equals. So our axis of symmetry is at x equals negative 1. The vertex then is, again, that is our x value that we just found. And then we have to figure out what the y value is if our x value is negative 1. So if x equals negative 1, I'm going to go ahead and put that in to the equation and see what we work out. So we've got y equals, so y equals negative 1 squared is 1, so 2 times 1 would be 2. 4 times negative 1 is negative 4 plus 6. So 2 minus 4 is negative 2 plus 6 would be our 4. So our vertex is at negative 1, 4. That is, our leading coefficient is positive, so that parabola is opening up. So that means that that is a minimum. Our y-intercept is when x equals 0. So we'd have 0 plus 0 plus 6. So our y would equal 6 for that y-intercept. So go ahead and try the u-try and come back and check your answers. Okay, so take a look at the do u-try. Let's see. Your axis of symmetry should be x equals negative 3. The vertex should be at negative 315. That is a minimum because we do have a positive leading coefficient. And our y-intercept is at 0, negative 6. The second one, your axis of symmetry should be x equals negative 2. Vertex at negative 210. That's a maximum because our leading coefficient is negative, so that parabola opens down. And our y-intercept is at negative 2, which we know if we write in a coordinate point would be at 0, negative 2. All right, if we take a look at example 5 on the next page, we're using the graph of a quadratic function. The problem says an acorn drops off a tree branch 70 feet above the ground. The function h equals negative 16t squared plus 70 gives the height of the acorn in feet after t seconds. What is the graph of this function? About what time does the acorn hit the ground? So if we take a look, we're used to making tables for our values. So we'd have time and height. And it tells us that at 0 seconds, okay, because if t were to equal 0, we could put that into the equation, or it tells us that it starts 70 feet off the ground, that's where it would start. So it's starting at 70 feet. So if we put some values in for time, and we're talking about seconds, so we could do half seconds and things like that. I would probably start with 1 just to see where that kind of led us. So we'd have negative 16 times 1 squared, which would just be 1, plus 70 would give us a height of 54. Again, we're just putting that value of time into our equation to see if it would work. And again, where do the values come from for our time? If you notice on your graph down here, it has 1, 2, 3, 4. So we could start with the 1 and kind of work our way up. So then if I tried 2, at 2 seconds, where's the acorn at? So again, I would put that into the equation. So I'd have negative 16 times 2 squared plus 70. So I'd have negative 16 times 4. That would be negative 64 plus 70, which would give me, it would be at a height of about 6 feet at that point. Okay, so I could kind of take a look. So if it's starting here, and at 1 second it was at 54, and at 2 seconds it's at 6 feet, so we're almost at the ground, I could probably go ahead and graph that, and I could kind of see where it was going to be. Now, if these are just seconds, we're just looking for approximately. So the acorn would land at approximately 2 seconds, in 2 seconds. Okay, it's probably going to be a little bit more, but we're just going to say about 2 seconds because it's pretty close. Now, if we went to 3, we'd end up in the negatives, and we can't really have negative height in this case. So, because we're talking about the ground, and they wanted to know about what time does the acorn hit the ground. So it hits the ground at about 2 seconds, in about 2 seconds. So that's what we're wanting for those. So go ahead and try the you try, and then come back and check your work. Okay, so if we take a look at this one is very similar to the other one. A child drops a pebble from a height of 30 feet above a lake. The function h equals negative 16 t squared plus 30 gives the height of the pebble in feet after t seconds. Graph this quadratic function, and about what time does the pebble hit the water. So again, we've got time and height. And again, at 0 time, at the beginning, it's at 30 feet. So I know I can start my graph is going to start right there. So I'm going to go ahead again. Our graph is at 1, 2, 3, 4. So I'm going to start at 1 and see how close I get here. So again, if we put a 1 into there, I'd have negative 16. Height would equal times 1 squared plus 30. So negative 16 plus 30, I would be at about 14 feet. So if I go ahead and graph that, I'm about right there. So it's looking very much like 2 is going to be way too much because I can see how my graph is curving downward and it's not going to make it to 2. I could, if I graphed that, kind of generalize about where it would go. And I could say if we were just rounding to the nearest second, it would take about 1 second. If I wanted to get a little closer, I could. I did, so I tried 1.25, and I got that I would be pretty close at 4.9 feet. So I would be at, I'd have to kind of measure that. That would be about right here. My graph's a little off. And you could try to get closer and closer. But if we're just kind of generalizing and not needing to get too specific, we could say about 1 second. So it would, what time does the pebble hit the water? Pebble hits the water in about 1 second, or a little over a second. Okay, and that's it for this lesson. You are ready for the homework.